Hello students and welcome back. So now we are going to talk about different coding styles that are supported in Verilog. So in this video we are going to talk about that what are the different Verilog coding styles, what is Dataflow coding and what is gate level coding. These are the two different coding styles that we have, and let us get started. So first of all, we need to talk about the level of abstraction and the coding styles. We had discussed that there are three levels of abstraction: behavioral, Dataflow and gate level. There was one more which is switch level, but we said we are not using it in the front end. So we have three levels. When it comes to the coding, we merge the first two and we name it Dataflow or behavioral modeling. That means using these two styles, if we code, then that is one common style, and the second style is gate level modeling. So broadly speaking, we'll be talking about these two coding style, Dataflow / behavioral and the gate level modeling. So when we talk about the Dataflow modeling, here we are basically defining the functionality of the system using some functions. Here we do not define any gate level structure or gate level relation in a single line. We are going to use several operators, and that can act on the given operands and they will produce the desired result. With the advanced and sophisticated systems coming in and the support of EDA tools, this style of coding is getting more and more popular as well as practical. The Dataflow modeling style is mainly used to describe the combinational circuits, the arithmetic modules kind of circuits. Now we are going to have a look at some of the examples. Here I am saying assign I1 and I2 into Y1. So we are taking logical AND of I1 and I2 and assigning it to Y1. We are now doing AND of I1 and I2 and taking the OR of complete thing with I3 and then assigning with Y1. This style is different from gate level because in gate level modeling, in single assignment, we can only use one gate. Here we are using multiple gates. So similarly, you can see at a delay of 20 units, we are assigning the 0th location of variable y as the complement of a bar and b bar and enable. So we can use multiple gates in a single assignment. We can also use different other kind of assignment which we will discuss throughout this training program. So let us have one more example. Here we have a module which is full adder having two inputs A and B, another input C in. So total 3 inputs and 2 outputs, sum and carry. So what we say, I need some additional signals S1, S2, S3, and then I use a technique called module instantiation. I use a half adder which was implemented using case statement as a component. I call it and then I map my ports of half adder with my given full adder. I use two such half adder, one with the instance D0, one with the instance D1, and I am assigning carry as OR of S2 and S3. Do not worry about all these assignments. We will talk about these in detail in our future videos, and we close it with AND module. So basically we are describing the behavior of a full adder using the behavior of half adders in this code. And if I give input A equal to 1, B equal to 1 and C equal to 0, my output will be sum equal to 0 and carry equal to 1. Now let us talk about the second style, and that is gate level modeling. Simple circuits, those have less number of gates which can be derived by optimizing the Boolean expressions. In those cases, we can use gate level modeling. Only a few logic gates are allowed for gate level modeling, and these are called primitives in Verilog programming language. The supported gates can be multiple input, multiple output, and tri-state logic based gates also. We can also use pull gates. So normally what we see that AND gate is a 2 input gate, but we can have AND gate with 3, 4 or more inputs as well. The supported gates are AND, NAND, OR, NOR, XOR and XNOR. So these are the gates that are allowed to be used using the gate level modeling. Now we also have multiple output gates. That means the output of my gate can be supplied to multiple different places, and these are buffers and NOT gate. Let us talk about some examples now. Here I say AND, that means I am going to take AND, and the first port will be my output port. So Y1 will be assigned as the AND of X1 and X2. When I say OR Y1, X1, X2, that means the OR of X1 and X2 will be assigned to Y1, and similarly XOR operation can be performed. Let us have a look at one more example. Here I have half adder using gate level modeling. So I have given the module name as HA_gate. There are 4 ports A, B, S, C. S and C are the outputs, A and B are my inputs. So now what I say, XOR D0 is the instance name. XOR of A and B will go to S, and AND of A and B will go to C. Half adder can be made using only these 2 gates. How it is done, we'll discuss that in the future videos. And that's all for the coding, and we say AND module. Here you can see in one single line we can only use 1 gate and 1 assignment. So this is about the gate level modeling. So students, now we know the different types of coding that we can do. Let us get started with the coding. So the first thing that we will do is we are going to design a half adder using the Dataflow modeling. We'll discuss that in our next video. Keep learning. Thank you.